Okay, today we're looking at 4.8, day 2 of complex numbers. The other day when we looked at day 1, we talked about radicals that had negative values underneath the radical or in the radicand. And we reviewed several different problems involving that. And of course, converting them to I. So one particular problem that I do want to go over that's number 6 in your notes that I posted looks like this before we do anything else. So we had root -8 times root -5 minus root 3. Remember, I told you that you can't multiply two radicals that have a negative radicand or simply a negative number underneath. And you always need to make those numbers positive. And the way you do that is you take the negative out front as I. So this becomes I root 8. This becomes I root 5. Now, from this point, what you can do, you can go ahead and put 8 in simplest radical form as 2 root 2, or you can go ahead and multiply them now that you have a positive number underneath. So if we do that and distribute I root 8 to both, you get I squared times root 40 minus I times root 24. When you're multiplying radicals, you multiply the numbers underneath. If you were adding or subtracting radicals, they would have to have the same number underneath, and you would treat them like x plus x equals 2x. But we'll get there in a little while. Remember that I squared is -1. And let's go ahead and break root 40 down, put it in simplest radical form, and let's do the same thing with I root 24. So we have root 40, and that will break down into 4 times 10. Remember, you divide 4 by perfect square, divide 40 by perfect squares, like 4, 9, 16, so on. You can't take the square root of 10, and 10 does not contain any perfect square factors, meaning that 4, 9, 16 will not divide into 10. We break 24 down into 4 times 6, same thing. Can't take the square root of 6, and no perfect square will divide into 6. Take the square root of the numbers that you can. So I can pull out square root of 4 in both cases. And if I take the square root of 4 and multiply it to -1, I get -2. If I take the square root of 4 and pull it out front with I, you have 2I and then root 6. Now, there's nothing else you can do with this because root 10 and I root 6, these are not like terms. So I can't combine those at all. Okay, the next part, what we're going to do today is look at adding and subtracting, multiplying, dividing complex numbers. Adding and subtracting is as simple as just combining like terms. Multiplying, you have to look out for powers of I, such as I squared, I cubed, like we looked at the other day. Then we're going to look at dividing complex numbers, which is the more difficult or the most difficult of all of those. Okay, remember that all of your answers are going to say leave it in standard form. And recall from the other day when we talked about that, it is A plus BI. This is number 7 in your notes, and we actually did one like this the other day. Actually, we did that one. Okay, we've already looked at really adding, subtracting, multiplying, and dividing, but let's just look at one like this. This says subtract and leave your answer in the simplest form. This is number 8 in your notes. So if we just drop the parentheses, make sure that both terms inside become negative because you distribute that minus sign. And this is what you have. And when you combine like terms, you're left with 2I minus 5. And In order to put that in standard form, you have to swap places. So we'd have -5 plus 2i. That's in standard form, a plus bi. Okay, the next concept that we're going to look at is dividing complex numbers. Okay, so you've learned in the past in math that you cannot leave a radical in the denominator. So if I have something like 1 divided by root 2, you've learned in mathematics that you would have to rationalize the denominator. And I'm going to show you the process involved in that. So we've never left radicals on the bottom unless we're dealing with a specific type of problem that will give you permission to do that, but rarely you ever do. So in this case, 1 divided by root 2, you would multiply the top and bottom by root 2 to get the radical out of the denominator. Okay, same situation. If you have I in the denominator, remember that I is equal to the square root of 1. So this is the same as, any other radical that you deal with. And you cannot leave I in the denominator. You can't have I in the denominator ever. Okay, I'm going to show you the 2 types of problems that you may see. And the first thing you want to do is just simply look at the denominator to see what process you need to follow. So there's going to be 2 types of problems. You may only have 1 term in the denominator. Okay, the other type of problem is where you may have 2 terms in your denominator. 1 term in my denominator, once again, I don't care what the top looks like. I can have 1 plus 2i, I can have 2i on the top, I can have a number on the top, it does not matter. If I have only 1 term on the bottom, such as 6i, 1/2 I don't have anything added or subtracted, but I do have I. Then what you're going to do in this case, when you only have 1 term on the bottom, you're going to multiply. This is how you would rationalize it. You're simply going to multiply the top and bottom, the numerator and denominator, by I. So multiply the top and bottom by I. And of course, if you multiply this by I, you're going to get 6i squared, which will turn into -6. So it takes I, or root -1, out of the denominator. Okay, for the second part, let's say you have something like this. Once again, I'm only looking at the denominator of my problem to see what process I need to follow in order to get I out of the denominator. So I would have 2 terms in the denominator. I've got 1, 2. And in this case, you're going to multiply the top and bottom by what's called the conjugate. I'm sure you've heard this word before in math. Conjugate of the denominator. So multiply the top and bottom by the conjugate of the denominator. Okay, some examples of what a conjugate is, if you've never seen it before. So notice that I have 2 minus 3i. The conjugate of that, so 2 minus 3i's conjugate would be 2 plus 3i. Conjugate of 1 plus 5i would be 1 minus 5i. Notice that the only thing that changes is the sign in the middle. Everything else, I mean, pretty much the sign of your second term is changing. But conjugate is simply where you have the same 2 terms, but you have a different sign in the middle. Okay, let's practice some division problems. Divide and simplify completely, and they want you to leave your answer in standard form. And this is number 9 in your notes. You have 2 plus 7i on the top, all divided by 5i. Once again, I'm only looking at my denominator to begin with. So I'm only concerned about 5i to see what process I need to follow in order to divide this. I only have one term in my denominator. So in that case, I'm going to multiply the top and bottom by I. So here we only have one term. So multiply the top and bottom by I. Sometimes on the top, guys, you're going to have to do the FOIL method. You may have to distribute, such as this case. Because notice you have I times 2 and I times 7i. So when you distribute I on the top, you get 2i plus 7i squared. And all of that's divided by 5i times I is 5i squared. Now it's just a matter of going through and simplifying, combining like terms. You know that you need to change I squared to negative I. So on the top, we have 2i plus 7 times negative 1 all over 5 times negative 1. I'm showing you step by step, but if you'll just remember that I squared simply changes the sign of the number of its coefficient. So then we have 2i minus 7 over negative 5. Now, this is not in standard form. How they're going to make you write this in standard form, you guys remember when we were solving those quadratics and you had to split up? So similar in nature. What you're going to do here is take this denominator that both terms in the numerator share, and you're going to separate it. So we have, you have a 2i negative 2i over 5. All I did was just move the negative to the top. Doesn't matter. So negative 2/5 I. And then look, this negative and negative are going to make that plus 7/5. But this is still not, and we wanted an a plus bi form, okay? So you need to put the 7/5 part in the front, and the I term goes in the back. So I'm sure you see why now. I told you that division was your more complicated of the processes involved, or operations. Okay, this is the most difficult of the division type of problems that you'll see. Okay, this is number 10. 8 minus 7i over 6 plus 5i. Now you have two terms on the bottom Once again, you're looking at your denominator at the first to figure out, do I have one term? Do I have two terms? What process am I taking? So we have two terms here. So you're going to multiply the top and bottom by the conjugate. So we want the conjugate of 6 plus 5i is going to be 6 minus 5i. Okay, so from this point, you need to FOIL on top. So this is what we have. I'm going to rewrite the problem to make it easier for you to follow. So we have 8 minus 7i over 6 plus 5i. This was your original problem. Now we're multiplying it to the conjugate of the bottom. So FOIL method or distribute. So just make sure that you multiply 8 to both terms there, and that's going to give you 48 minus 40i. Also make sure you multiply negative 7i to 6, negative 42i, and negative 7i to the last term. So that will give you plus 35i squared. All over. And once again, do the same thing on the bottom. Make sure you multiply 6 to both terms. So that's going to give you 36 minus 30i. Positive 5i to both terms. So that'll give you plus 30i minus 25i squared. Okay, combine like terms and make sure that you change I squared to -1. So this is going to become -1 and this will become -1. So notice that it's just going to make this become minus 35 and I squared goes away. This is going to become plus 25, I squared goes away. So on the top we have 40 and then when you combine like terms here, this gives you minus 82i. Then we said minus 35 at the end. All over 36, those terms go away, you're left with plus 25 at the end. Notice how the conjugate allows you to not have I in the denominator. That's why you do it with the conjugate. So then we have 13 minus 82i all over 61. Okay, but in order to split this up and to put it in A plus BI form, we want to separate and say 36 over 61 minus 82 over 61I. And none of that will reduce. Just make sure that your fractions 32 over 61, 13 over 61, 82 over 61 will not reduce, and they won't. Okay, the next thing that we need to look at with 4.8 complex numbers is solving quadratic equations. You remember when we were solving quadratic equations that if we wound up with a negative discriminant, remember if b squared minus 4ac come out to be negative, we would say there's 0 real solutions. Well, yes, there's 0 real solutions, but we need to look at what the solutions would look like in the complex number system or imaginary realm. So in all of these, so you've already done this in chapter 4, earlier chapter 4, we're still in chapter 4, solving quadratics. And remember the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. And remember always to make sure that your quadratic equation is in ax squared plus bx plus c equals 0. That all of your terms are on one side and it's set equal to 0. You will not be able to factor any of these quadratic equations in this section, although you can attempt to see if they will. And this is number 11. It asks you to solve 5x squared plus 3x plus 1. It's already set equal to 0 for you. Notice that even if you did take 5 and multiply it, you would have 5. And there's not, the only two numbers that multiply to 5 are 5 and 1, and they do not combine to give you 3. So that's why it doesn't factor. You have to use quadratic formula in this case. So A is 5, B is positive 3, and C is 1. When you go through and plug in, you're going to have the opposite of B. So negative 3 there, plus or minus square root. B squared is 9. Minus 4 times A is 5 times C is positive 1. And this is all divided by 10. 2 times A, which is 10. Okay, go through and simplify as much as possible. So we have negative 3 plus or minus square root. You have 9 minus 20, and that's going to give you negative 11. Now, you know that 11 can't break down any further into simplest radical form, but what you have to do in this case is you always have to bring out the negative, no matter what, as I. Now, if 11 could break down anymore, you would, of course, do that. But it won't here. So we have negative 3 plus or minus I root 11 all over 10. Now, once again, you need to separate these answers and put them in A plus BI form. So we take negative 3 tenths plus I root 11 over 10, comma, negative 3 tenths minus I root 11 over 10. And once again, always double check your fractions, make sure they won't keep simplifying, and this will not. If your radical needed to break down, please do that, like I said. Okay, the last thing that we got to talk about in 4.8 is graphing complex numbers. Okay, when you're graphing complex numbers, this is the same situation as if you were graphing an order pair in the coordinate system. But the complex number system, this is your imaginary axis. Imaginary axis, and this is your real axis. And so this is what it would look like. So on your imaginary axis, you would have like 1i, you would have like 2i, this would be negative I, negative 2i, so on. On the real number axis, of course, we would just say like this is 1, this is positive 2, this is 3, and so on. Negative 1, negative 2, negative 3. So if you are graphing, if you have the complex number a plus bi and you were asked to plot that complex number. So whatever your real number part is, like you're going to graph the point, you're going to graph a, b, just like you would an ordered pair in the coordinate plane. So you graph AB just like normal. The only difference is this is called the real axis and not the x-axis, and this is imaginary, not y. That's the only difference. So graph your point AB. Notice you don't take the I. It's just A and whatever the coefficient of I is. Now, another thing that's going to ask you to do, and you're going to see this next year again in pre-cal, it's going to ask you for the absolute value of the complex number. Now, you know, of course, the absolute value of 5 is negative 5. The absolute value of 5 is 5. The absolute value of negative 5 is also 5. And so we have to develop a way to find the absolute value of a complex number in the same sense. And the absolute value of 3 is 3, so on. So there's a formula. If you see this notation, you will have the absolute value of your whatever your complex number is, and you're using this formula. Square root of a squared plus b squared. Notice, once again, you do not have I here. To find the absolute value of a complex number, you simply take A and the number in front of I, square them, add square root. All right, some of your problems in your Math Excel say to, like this is number 12 in your notes, it'll say in part A to graph or plot the complex number. And then in part B, it'll say find the absolute value. All right, and this is what you have. You've got this complex number, negative 5 plus 2i. So we're graphing the point. You're simply graphing the point, negative 5, positive 2. That's what you're plotting. So if you go up on the imaginary axis, that's I, 2i, 3i, so on, 4i, 5i, and then we have 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5. So negative 5, 2i is there, or negative 5, 2. So notice that we graphed it just like we would the point, negative 5, 2, you go left 5, up 2. Done. In part B, they ask you to find the absolute value of that complex number. So this is what it's going to look like, but all you have to do is simply square negative 5, square 2, add that, so you get 25 plus 4, 29, and then see if that will simplify. This will not simplify, so we leave it like that. Okay, that's 4.8, day 2. Just message me if you have any questions. I hope you guys have a great Thanksgiving break.